Hello students, and welcome to the continuing series of videos on area between curves or applications of integrals. And let's look at an example here where we're asked to find the area between two different equations. The first one being x equals 3 minus y squared, and the second one being y equals x minus 1. Okay, and of course, what makes this a little bit tricky is that we're not given two functions in terms of x. We're given a function in terms of x and a function as x is a function of y in this case. So we have to treat this problem a little bit differently, and I'm going to start out by graphing just so that we could visualize this picture. Okay, so I've graphed the easier of the two here, which is the simple line y equals x minus 1. Now we're going to graph the more complicated one, which is the function where where x is a function of y. Okay, so some notes about this. I mean, we know that this is going to be a parabola of some type, okay, but it's going to open sideways instead of up and down. We know a few things, that when y is equal to 0, x is going to be equal to 3. Okay, so that much we know. When y equals 0, x is going to be equal to 3. And then we also know, let's try some other points. So we can try 1. When y is equal to 1, x is going to equal 2. Okay. And when y is equal to negative 1, x is also going to equal 2. Oops, sorry. When y is, I don't know why I put it there. When y is equal to 1, so that's up here, x is going to equal 2. Okay. And when y is equal to negative 1, x is also going to equal 2. Okay. So maybe I should make a table of this. This will be a little bit easier to see. Okay. So let's start out again. When y is equal to 0, you put 0 in here, you get that x is equal to 3. So 3, 0 is the point on the graph. When y is equal to 1, x is going to equal 2. And when y is equal to negative 1, x is also going to equal 2. So 2, 1, and 2, negative 1 are here. So from those points, I think we can make that the sketch is going to look something like this. Okay. And what we are looking for is this area in between, this little sliver right here in between the two graphs. Okay. So we don't know the limits of integration, so we're going to have to find the points of intersection. And this time, we're going to have to do it algebraically. And it's not too difficult to do. We're just going to solve this one for x as well, and then set them equal to each other. So I have one equation is x equals 3 minus y squared. The second equation is y equals x minus 1. So that means y plus 1 is equal to x. So 3 minus y squared is equal to y plus 1. And that means, let's see, 0 is equal to y squared plus y minus 2. And just solve this quadratic, and we get that y is equal to 1. And y must also be, whoops, I was writing off the screen there. Y is also equal to negative 2. So that's these two intersection points. And once we know y, we can put it back into the given equation and use that to solve for x. So this intersection point here is when y is equal to 1. So x must be equal to 2. And then this other intersection point when y is equal to negative 2. So x must be equal to negative 1. Okay, So this graph was not drawn up to a very good scale. Okay, but there you have it. So these are the 2 points that we're going to integrate from. So now let's integrate. So to integrate, and this is where the part where it gets a little bit challenging, because if we integrate it, we have to be very careful, and we have to find this region right here. So that is the integral from -1 to, that looks like +1 there, okay, of the top function, which is x minus 1, minus the lower function. And keep in mind that right now it is a function in terms of y, and we need to convert this into a function in terms of x. So solving for y, we get x minus 3 equals -y squared. Thus 3 minus x equals +y squared, and that means plus or minus the square root of 3 minus x is equal to y. Okay, so there's actually 2 functions here for y. It cannot be done with a singular function. And so this is the lower one right here. This curve, this bottom red curve is negative square root of 3 minus x. So then this is x minus 1 minus negative square root of 3 minus x dx. Okay, so that only captures this one area. Then we have to deal with the, let me get a different color marker here. Then we have to deal with this green area right here. Okay, and this green area is the integral from 1 to this point right here, which is 3, of the x-axis is the top function, and then the lower function here is still negative root 3 minus x. So this is going to be negative, because the x-axis is basically just 0. I'll write this in here. So 0 minus negative root 3 minus x dx, okay, plus the final chunk, which is from here, okay, but that too is not very straightforward. So you have 2 parts here. You have a part where, let's see. Sorry about that. You have 2 parts here. You have this little chunk right here that I'm trying to outline with, okay, because that's basically a little triangle and then a little curve. Okay, so the triangle here is, I think, the simplest thing about this. We're integrating from 1 to 2. So write this. Let's see if I get it all in the same picture here. We're integrating from 1 to 2, and the function that we're dealing with is x minus 1, okay, dx. And then you have the extra little curve out here, and that is the integral from 2 to 3 of the top curve here, which is positive root 3 minus x dx. Okay, and if you add up all of these integrals, then we'll finally get the answer that we're looking for. Okay, and of course, if you had a calculator to use, you could just type all this in. Even then, this is going to take some amount of work. Okay, but you would still get the right answer. Okay? And maybe you're thinking, is there a better way? And of course, absolutely, there is a better way. So I'm going to leave it to you as an exercise to finish this problem and figure out what this answer is. And I'm going to start another video where I discuss how to deal with this problem in a better way, or in a slightly different way that may be cleaner.